Okay, Bismillahirrahmanirrahim. We continue our lesson today with chapter 3, Introduction to Z Formal Specification Languages. This one is a continuation from uh, last week. Okay, okay what is a Z specification? Z specification is basically is a language uh, that use the schema language uh, to structure and compose mathematical descriptions that collating pieces of information, encapsulating and naming for reuse. Okay, and then it is a second component of Z notation for the first mathematical logic and a set of theory. It contains mathematical logic and a set theory for the set. Yeah. Okay. Logic and set theory. Okay, then as you can see, for the schema contains two main components. First one is the dynamic. Secondly is static. Later this one I explain it at the end of the slide. Okay, for static, it consists of state, condition of the variable, and then it also consists invariant, and then for the dynamic uh, includes operations, relationships, input, and also output, and then the changes of the state. Okay, so far the other question here. Okay, okay. Yeah, for the static, the state it can occupy, and then for the invariant relationship that are maintained as the system move from state to state. This one invariant. It move move out the state. And then for the dynamic, the operation that are possible, the relationship between input and output, and then the changes of the state that happen. Okay, later in this slide, uh, we also see how the schema language allows different facets of system interface of the system to be described separately and then related and combined. For example, the operation of system when it receives a valid input may be described first, and then description may be extended to show how errors in the input are being handled or managed, or the evaluation of single process in complete system may be described in isolation. Okay, we can see later on uh, uh, a single process or combined process related to the system. Okay, ZAC as a specification language. Okay, this one is a little bit about the history of the ZAC language. Okay, okay, as you can see, for the history in 1974, that Jean Raymond Abriel was published data semantic. He used several notation in mathematic notation that would later be taught in the University of Grenoble in the end of 1980s. And then Abriel also wrote the internal notes on the Z notation, and then it developed further in a programming group at Oxford University. since the late 1970s. Till now, everyone has said that Z is so named because it ultimate language. Although the name Z is, we can interpret this one as a Zarmelo. Zarmelo is basically associated with the Z notation through the use of Zermelo-Frankel set theory. Set theory. Okay. And then for the Z notation, also use ASCII. ASCII, just like API language. Okay. It uses many non-ASCII symbols. The specification include suggestion, rendering, notation symbol in ASCII and LaTeX. Okay, we have ASCII and LaTeX. Okay, so ada question ke? Hamizan, do you have any question? Boleh ke? Again. Okay, we look Z as specification language. We continue. Okay, for Z as specification language, we can see this one for the Z is basically built from a component that called schema. The schema is use a logic or set of theory. And then other than that, Z also uses a geometric set, theory, lambda calculus, first order, predicate logic, and so on. And the schema itself is based on a mathematical description. For example, we have soul, and then we have seed, we have partial function here. Later, I describe what is a partial function, customer, and then seating as a P, we define as a predicate, predicate as a C. And then we have a constraint, domain soul as a subset of a seating for this one. Okay, many of the schema are based on the specification building blocks. Okay, building blocks that also use graphical representation to make use of Z specification easier to understand. And then the benefit of mathematical notations of schemas that allows the building of formal completeness and also consistency proof to validate the specification. Okay, this one is the benefit. Okay, it allows to building the formal completeness. Okay, by reuse functions. Later we see this one. Okay, okay. For the rank schema, they have two types. First one is horizontal, like this. Okay, we have a declaration, and then we have constraint. Okay, for the vertical type, we have declaration by using this bar, okay, lines. Okay, we have a splitted vertically declaration and constraint. Okay, interior specification entities and define invariant predicates over these entities. Okay, and then for the value, consistent, and then goes to the process. This one is the schema, how the schema works. Okay, some predicate have side effect that changes the state of the entity involved. Okay, we have predicates that have side effect. Side effect here, we have a pre and post condition. Okay, a schema can also be included in other schema. It also can combine. This one can combine by using this junction. This one is this junction. I think you have learned in discrete mathematics. Kalau apa kalau kuning Oh, tak nampak pula kuning. Okay, any question? Ada soalan ke? Okay, this junction. Oh, tak nampak this junction. Okay, names are local to schema and in many respects, Z schema are akin to object because we want to reuse. We want to reuse. Sekejap Saya share balik. Okay, in many respects, they are akin to object because we want to reuse. Okay, ada soalan ke? Tulizia, okay. Mimi, Syamimi. Then, okay, this one is the some of the problem. Storage tank monitoring. It is monitored by a control system. The system consists of container which hold something and indicator panel will also indicate the current field level and danger level. It is consisting of two, one, and two danger level, two condition. Okay, this one we have invariant, which means that it associate with the predicate. If the storage tank goes over the danger level, and then a warning light must be lighted on the indicator panel, and then field operation must be specified as to ensure the tank to be refilled but never overfill. This one is another function. Okay, okay. This one function number one. Okay, and function number two. Two. Okay. Yeah, this one is container specification. We have a schema name, schema variable declaration. We have a predicate. Predicate here. It also can be set, set or predicate logic predicate. And then we have a container. Container. This one is vertical. Vertical. Okay. Okay, declaration and constraint. Any mathematical description will involve the declaration of the identifiers and constraint upon them. And then informal specification, group of identifier may be used to describe compound object or related property. Okay, we define a schema and use them as declaration, as a predicate, and as a set. Okay, it can be three types. First one as a predicate, as a set, or declaration. Okay, for the schema name, naming schema, we may give names to schema and use this name to refer the corresponding pattern of declaration and also for the constraint. The name must be integral schema name which equivalent to uh, container. Okay, equivalent to, okay, we have schema equivalent to container. Symbol equivalent. Ini. Uh, okay, two schema are set equivalent if they declare the same set of identifier with the same time and impose logically equivalent constraint upon them lah. Macam mana kita nak gunakan ni equivalent ni? If it said that have a same identifier, okay, same identifier, okay, with the same type, okay, same type, and impose logically equivalent. Boleh? Siapa yang tanya tadi? Hamizan. Boleh? Okay, we container schema name. We have a content as a natural number, capacity also as natural number. This one in between declaration is a semicolon. Okay. Okay, for the exact notation, schema includes name. Okay, name in place of declaration. We have place also for the predicate, and then we have also place of set. And then we have a signature introducing the entities and the type, and then predicate. A part defining the relationships between the entities in the signature by stating logical expression. Okay, greater than or equal to, less than or equal to, which must always be true. It is also named as invariant. Okay, for the invariant, I think I have explained it. For the invariant, is a pattern, uh, function, quantity, or property which remain unchanged. This one is invariant, remain unchanged. Because of what? Because it always be true. Okay, indicator specification. Okay, we have an indicator and then we have light on or off, and then we have a reading natural number, danger natural number, and then we have a predicate light on, okay, reading, and then this one is a logical expression for invariant. And then if the storage tank goes beyond the danger level, a warning light must be lighted in the indicator panel. Okay. Okay, this one is a function. Function. Okay, we have a container. Okay, and then we have an and then we have a storage tank. Storage tank. Okay, here We have a reading capacity and danger level to read the content of the storage tank. And then specification of storage tank. We have a content capacity reading, danger level as a natural number, and then light on or off. And then here the predicate, we have used the logical expression, content less than or equal to capacity, and so on. Okay. Okay, partial specification. What is partial? Partial means that the function or specification is not full. Okay. Okay, and then uh, we have delta. Delta uh, in Greek. In Greek mean a change, and Z symbol is not change. And then we have input. Okay, and then we have output. Okay, and then we have single quote. The single quote a variable after the operation performed, defined after. Okay, we have content plus amount as an input, question mark, less than or equal to capacity. If you have output, you put the what you call exclamation marks. Any question? Ada soalan ke? Priscilla, is it okay for you? Okay, if you have a question, you should ask. And then for the Z convention, schema name prefixed by the Greek letter delta means that the operation changes some or all of the variable introduced in that schema. We have delta, I have explained to you. And then we also have a variable name decorated with the question mark. Question mark represent input, exclamation marks mean output. And then a variable name decorated with a quote mark, quote mark or single mark represent the value of the state variable after operation. Okay, after the operation. Okay, this one like that. Do you have any question? Yeah, and then we have the most fundamental operation by the use of the assignment that change the state of the system. For example, like this. Okay, capacity equal to 250,000. Okay, okay, and then we have invariant. Invariant. Okay, invariant that describe the regularities between state changes. Okay, and then we have a prefix by the Greek letter Z, which means that define the operation does not change the value of the state variable. And then a variable name decorated with the exclamation marks represented the output. Output. Okay. Okay. For the Z schema in a vertical form, normally we use the schema name. Okay. Normally we use this one, block. And then we have a declaration here. And then we have predicate. Okay, ada soalan ke? Okay, sure. Okay, normally for the two-dimensional graphical notation, it explains the state spaces and also the operations lah. Okay, this one feel okay. Feel okay. We have delta here because the storage tank will be changes. It is a temporary keep changing because of the amount is a natural number, and then the content equal plus amount as a input. Input here is less than or equal to capacity. Okay, then we have storage tank field operation. We have overfill. Overfill must be V symbol because of what? Because of the uh, amount. Insufficient tank capacity will be deducted the field cancel. Okay, this one is delta is not changed. Storage tank will not change because the capacity. Let's say the capacity is 250,000 liter. It is a fixed number. Okay, like this. It is fixed. Okay, capacity is 250,000 is fixed. It's not invariant. It is a constant. Constant. Okay, and then we have fill okay. This junction by the overfill is combined two function. Okay, this one is this junction. Okay, okay, full problem specification. This one we have container. Okay, content and capacity and so on. This one is we using the vertical, and then we have fill okay. Okay, this one is vertical format. Okay, any questions so far? Okay. Yeah. Okay, and then operation specification. Define the normal operation as a schema, and then we define the schema for exceptional situation. Okay. Uh, in specifying a system operation, we must consider the following operation for the schema. The object are accessed by the operation of this. Okay, the object are known to remain unchanged by the operation. The object may altered by the operation. Okay, and then we have a precondition, and then we have a postcondition. Okay, for the precondition, yeah, precondition. The thing that must be true for the operation to succeed. Okay, and then we have postcondition. Okay, this one the thing will be true after the operation if the precondition was satisfied before the operation. after true after operation. Okay. And then Z notation. This one schema include identifying the schema, signature, and also predicates. And then convention. For the convention, marks before the schema, delta means changes, Z mean non-changes. Marks, question marks mean input, exclamation marks mean output. And then the single quote represent the value of the variable after an operation. This one is post condition. Okay, this one if you go by the symbols. Okay, we have S as a set of X, F is finite set, member, not member, subset, union, intersection, different, empty set, natural number, integers number. Okay, and then we have a cardinality. Okay, and then we have a partial function and total function. Partial, which mean that if you have x and y, and then it map only partial functions. Let's say 1 to 2 to b and 3 to d. But c and e is not mapped. And then we have a domain of f, range of f, and then extensional function, extensional function of definition, and extensional addition of mapping. And then we have a logical operation that you learn in discrete mathematics. Okay, for the key point, Z specification are made up of mathematical model that define the system state and system behavior, and also some definition of operation on that state. And then Z specification is presented as a number of schema. Okay, this one functions. Then schema may be combined to make a new schema by using disjunction. Okay, and then operation are specified by defining their effect on the system, pre and post. And the operation may be specified incrementally by using the logical operation. Different schema can be combined to complete the specification. One partial or fully function, fully partial. Notation is used in very cryptic. Very cryptic mean you need to have a better notation. Better notation in a graphical format. Through great effort is made toward understandability. Okay, guys. Later I give you the Z specification example. Please read this one, and then please do some reflection in Padlet. Padlet. Okay, for example, this one is the data dictionary that have several functions or operation. Okay, we have a type definition. Schema may also be used for type definition. The predicate serve as a constraint of the data type. Okay, we have a specification using functions. Okay, then we have a data dictionary modeling. We have add. Okay, we have lookup, delete, replace, and extract. Okay, for data dictionary entry. Okay, we have a name, we have a description, we have a some model type, and then we have creation date. And then okay, you look at this one is partial function, partial name, domain name, domain name. Okay, why it have partial? Because data dictionary entry is not have all of the name. Okay, so you want to have delta, you want to add, you add or initialize the data. Okay, this one delta, and then the dictionary code mark, single code mark is equal to empty set. This one for initialization. And then we have add success, add failure, and then lookup operation. Okay, function overriding operators. This one is overriding function with the same name but different attribute. Okay, and then we have a replace operations. Okay, deleting the entry. Okay, using the domain subtraction return by this one. Okay, and then delete entry, extracting specific data type. Okay, okay, this one is another example, birthday book. Okay, we have a system which record birthday, people birthday, and then operation must include the additional enquiry of the birthday lah. System must be able to give a list of birthday occurring on any given day lah. Okay. Okay, this one I have explained. We have a static and dynamic aspect of the system. Static means it can occupy invariant relationship constraints that are maintained on the state as its values are changed by the operations. This one changed by the operation. Okay, and then we have a dynamic. Dynamic. Okay, operation that are possible on the system state. A relationship between operation based on input and output, and then the change of the state that happen during the application of the operation, including in variable. Okay. Okay, we have a data dictionary modeling. We have add, find, and remind. Okay, guys, ada soalan ke? Do you have any question? Is it okay? They have four or five example. You need to read this one. Later, I give to you the slide. Ada soalan ke? Ya. Yeah. Ha. Nama function tu lah. Predicate logic. Yang mana? Yang mana tak faham? Letak apa? Ha. Hmm. Yang ni dia letakkan variable lah kat sini. Lepas tu yang ni predicate ni dia letak, dia compare lah. Compare variable yang ada kat atas ni. Comparison. Ha. Ha. Predicate lah. Predicate ni kan dia compare apa logical operator. Dia boleh jadi predicate, boleh jadi set. Kan ada tiga tadi. Predicate, boleh jadi set. Lagi satu apa? Ada tiga tadi yang saya bagi tahu tadi. Mana satu lagi ni? Ah, predicate, set or declaration declaration. Yang nombor tiga declaration kat sini. Skema predicate ni. Boleh? Lagi ada soalan? Aisyah boleh? Let's just have a look.